Hello students, welcome to my YouTube channel. In this video lecture, I am going to answer questions from Keith William Weight and Balance book. I'm going to answer questions from the very first chapter, Basics. Now this first chapter called Basics has some 120 questions. So we are going to solve all the questions one by one. Most of them are formula based, conceptual based, the definitions and simple numericals. So I hope you have watched the previous video lecture in which I solved the questions starting from question 51 to question 60. And now in this video lecture, I'm going to solve the next 10 questions 61 to 70. So let's start. What is the standard baggage allowance for passengers on Joint Aviation Rules certified aircraft with more than 20 passenger seats operating within the European region? So for such aircraft, which is operating within the European region, the maximum standard baggage allowance is equal to 13 kg. Okay, in the European region, it is equal to 13 kg. Next, regulated landing mass is maximum takeoff mass minus trip fuel, maximum takeoff mass minus trip fuel and startup taxi fuel, lower of maximum landing mass and performance limited landing mass, greater of maximum landing mass and performance limited landing mass. So, we always start with the basic empty mass or the standard mass of an aeroplane. Now, when we add variable loads to the basic empty mass, we get dry operating mass. Dry operating mass plus fuel on board or takeoff fuel is equal to operating mass. Dry operating mass payload will be equal to zero fuel mass. Operating mass plus payload will be equal to takeoff mass. In a similar manner, zero fuel mass plus fuel on board will also be equal to takeoff mass. Another way you can find takeoff mass is when dry operating mass plus useful load are added. So what is useful load? Useful load is nothing but fuel on board plus payload is your useful load. Okay, dry operating mass plus payload, fuel on board plus payload is equal to your useful load. Now when DOM plus useful load will give you takeoff mass. Next, when you subtract subtract trip fuel from takeoff mass, you get landing landing mass. Now here they are talking about maximum takeoff mass. This maximum takeoff mass is the maximum structural takeoff mass. Now also I have, if you have watched my other payload numericals video lectures, you will you will be knowing that whenever I am doing those payload numericals, I follow two steps in solving them. Step 1, make three columns, takeoff mass, the landing mass, and the third one is the zero fuel mass. Now in the takeoff mass column you write a value which is the lower of performance limited takeoff mass, and maximum structural takeoff mass. Okay, so in the first column you write a value which is the lesser of performance takeoff mass and maximum structural takeoff mass. In the landing mass column you are going to write a value which is the less of performance limited landing mass and maximum structural landing mass, and to that you are going to add trip fuel. In the zero fuel mass column you are going to write a value which is an addition of zero fuel mass plus fuel on board. So all these three columns will give you different takeoff values. Okay, and you're going to select that takeoff value which is the least of them all, and that particular takeoff value will become the regulated takeoff mass, Now here the statement 62. Okay, maximum takeoff mass minus trip fuel. So it's right that takeoff mass minus trip fuel gives you landing mass. But the takeoff mass that we are talking about over here is maximum, is correction, is regulated, is not maximum takeoff mass, but it is a regulated takeoff mass minus the trip fuel, minus the trip fuel. Okay, so your takeoff mass will be regulated takeoff mass. Regulated takeoff mass means what? Means that takeoff mass which is the least of all takeoff values obtained from takeoff, landing consideration, zero fuel mass consideration. So you are going to check that your the takeoff mass with which you are going to take off satisfies the departure place conditions, cruise conditions, landing conditions, zero fuel mass conditions as well. Okay, so you are going to check all the boxes and see that everything is safe. That's why we go with the smallest takeoff value. Uh, so yes, so regulated takeoff mass minus trip fuel gives you landing mass, not the maximum structural takeoff mass, because maximum structural takeoff mass can be one thing, performance limited takeoff mass for that particular day. What is performance limited takeoff mass? Nothing but takeoff mass calculated, or the maximum takeoff mass calculated considering atmospheric conditions like temperature, pressure, humidity, runway lengths available, etc. Okay, so performance also influences our aircraft behavior, the climb behavior, the takeoff distance required, etc. So not only structural limitation is important, but takeoff limitation is also important. Performance takeoff. So that is also calculated. So option alpha will be the wrong one. Maximum takeoff mass minus trip fuel and startup and taxi fuel also? No. Trip fuel is exclusive of startup and taxi fuel. So you need not minus that thing again. And again, maximum takeoff mass cannot be the term. The lower of maximum landing mass and performance limited landing mass. Yes. Like I said here, in the landing mass column, you are going to select one value of landing mass. You will be given two different landing mass values. The structural landing mass limitation and the landing mass limited by performance, like the pressure altitude of airport, temperature conditions, pressure conditions, runway lengths, etc. Okay, so you are going to select a lower value, which will be much safer. So that will be called regulated landing mass. And to that regulated landing mass, you are going to add trip fuel. So when you add regulated landing mass plus trip fuel will give you regulated takeoff mass. You are going in the reverse direction. So option Charlie is the right one. Delta is again wrong because you select a lower value, not the higher value. 63. Maximum allowable landing mass. Now maximum allowable landing mass is nothing but your regulated landing mass. Same thing, different name. So maximum takeoff mass minus trip fuel, no. It cannot be maximum takeoff mass. It has to be a regulated takeoff mass. Greater of maximum landing mass and performance limited landing mass, no. Maximum takeoff mass minus trip and startup fuel, no. Lower of maximum landing mass and performance limited landing mass, yes. So this question is similar to the previous question, only that they have used a different term here, maximum allowable landing mass, which means regulated landing mass, the landing mass which is allowed to be to land your aircraft with. So that is the meaning. Which of the following best defines the takeoff mass of aircraft? So takeoff mass is nothing but landing mass plus trip fuel. Yes, landing mass. Landing mass plus trip fuel going in the reverse direction will give you takeoff mass. Takeoff mass minus trip fuel will give you landing mass. So this sounds right. Landing mass plus total fuel. Okay, so this is a vague term. Total fuel means we are definitely not going to include startup fuel, taxi fuel, because we will have finished consuming that fuel even before we reach the takeoff point on the runway. So this is again wrong. DOM plus takeoff fuel and traffic load. Okay, so DOM plus takeoff fuel plus traffic load. So DOM plus takeoff fuel plus traffic load equals to takeoff mass? Yes, because DOM plus useful load is also equal to takeoff mass. So this also sounds right. So let's take this. DOM plus takeoff fuel and payload. Delta. DOM plus takeoff fuel and payload. This is wrong. Now traffic load is inclusive of payload and non-revenue load. Okay, it's already inclusive of payload and other non-revenue load. So delta will be the wrong one. Bravo will be the wrong one. We are left with alpha and Charlie. Now alpha, landing mass plus tip fuel is equal to takeoff mass. That is, this statement is right, but it cannot be true all the times, because many a times we carry your takeoff fuel will not only include trip fuel, but will also include contingency fuel, correct? It will also include uh, alternate fuel, diversion fuel, some extra fuel if preferred by the captain of aircraft, right? Reserve fuel. So that's why option alpha is not the appropriate one. So there are two options, alpha and Charlie. So Charlie is the more appropriate one because DOM plus takeoff fuel and traffic load will hold true for all times, at all times. Okay, so alpha eliminated, we are left with option Charlie. Because alpha cannot be the right one all the time, but Charlie can be the right one every time. 65. What is the standard baggage allowance for passengers on JAR certificated aircraft with more than 20 passenger seats operating on intercontinental flights? Intercontinental flights means flights originating from outside Europe, entering Europe. So that means the baggage limit, the standard baggage allowance for such flights are is equal to 15 kg. Is equal to 15 kg. If the flight is to be operated within the European region, the weight is 13 kg. If outside European region, the weight is equal to 15 kg. Ramp mass. What is the ramp mass? So ramp mass means the weight of your aircraft when it is parked on the ramp. Now on the ramp, the weight of your aircraft will be the maximum. It will be fully loaded with passengers. The wing tanks will be full of fuel, uh, and yeah, cargo, baggage, non-revenue loads will also be there. So at the time of ramp, the weight of aircraft will be maximum because you at ramp aircraft doesn't run on its engines. Okay, so no consumption of fuel happens. So if fuel is not consumed, that means the weight of aircraft will not decrease with time, right? So ramp mass is nothing but gross mass, the total mass at the start of taxiing, all up mass before startup, gross mass on arrival at the destination, additional fuel, additional fuel to be loaded for startup and taxi to the takeoff point. So ramp mass is gross mass at the start of taxi, at the start of taxi. Okay, so that is the right answer. Next, the maximum zero fuel mass of aircraft fitted with only wing tanks. Okay, wing tanks is related to wing bending stress during takeoff. It's related to maximum takeoff mass. It's related to wing bending stress during landing. Doesn't apply. So it's option A. Maximum zero fuel mass is specified by the manufacturer of aircraft so as to evaluate the maximum stresses that can be imposed on the wings at the time of takeoff. So zero fuel mass is nothing but the mass of aircraft without any usable fuel. That means the central mass of aircraft. Let's say this is your aircraft. Okay, this is your aircraft. Zero fuel mass will be means your aircraft is full of payload, all passengers in the center of aircraft, that is fuselage. But there is no fuel tanks, there is no fuel in your fuel tanks. Okay, now your wings have to generate all the lift and lift your aircraft up in the atmosphere. Okay, it has to bear or withstand the loads of this central fuselage, which is full of cargo, baggage, non-revenue load, passengers, right? So so that is zero fuel mass. So you can load your aircraft with payload or traffic load only up to a certain point. If you exceed that point, that extra traffic load will be imposing tremendous stress or loads on the wings of your aircraft. Okay, so that's why zero fuel mass is mentioned, maximum zero fuel mass is mentioned, and it's related to wing bending stresses, stress imposed on wings at the time of takeoff. At the time of takeoff, when your aircraft is very heavy, heavy with passengers, traffic load, as well as fuel in the fuel tanks. Okay, so that is the answer. 68. Which of the following best defines the center of gravity datum? So let's consider this is your aircraft. Okay, let's say this is your aircraft. This aircraft will have two limits, namely the forward limit and the aft limit defined by the manufacturer, within which the center of gravity of your aircraft can shift or move. Now the center of gravity is a reference to a specific datum. Okay, is a reference to a specific datum. That means all center of gravity calculations begin from this datum. This datum can be outside aircraft, it can be inside aircraft. Okay, there are two possibilities. And further, all center of gravity calculations are done along the longitudinal axis of aircraft, an imaginary axis that runs from the nose of aircraft to its tail. Fine. So, CG datum is rearward CG limit no, forward CG limit no, a point specified by the manufacturer as the reference point for all CG calculations, a point specified by the regulating authority like DGCA as the reference point for all CG calculations. So datum is defined by or specified by the manufacturer of aircraft. Okay, and that datum is a fixed point, is a fixed location. Okay, next. What is the zero fuel mass of aircraft? So zero fuel mass, takeoff mass plus startup and taxi fuel wrong. Takeoff mass will be exclusive of startup and taxi fuel because all this startup and taxi fuel will have been consumed till you reach the point of takeoff on the runway. DOM plus traffic load, yes. Operating mass plus fuel on board, no. Operating mass is already inclusive of fuel. So you will not add another fuel again. Operating mass minus fuel. Okay, operating mass minus fuel load will give you dry operating mass. Will give you dry operating mass. So let's look at this slide. Here, dry operating mass plus payload gives you zero fuel mass. Dry operating mass plus fuel gives you operating mass, just the operating mass. So operating mass minus fuel will give you DOM. Okay, so the correct answer is this one. Okay, DOM plus traffic load equals to zero fuel mass. What is the DOM of following aircraft? So we have to calculate the dry operating mass. When takeoff mass, zero fuel mass, two zero fuel masses are given. Useful load, which is a combination of fuel on board or takeoff fuel plus payload or traffic load interchangeably. Takeoff fuel, startup taxi fuel, basic empty mass. So dry operating mass can be calculated in two ways. The first way is the simple formula basic empty mass plus variable loads equals to dry operating mass, right? But we do not have variable loads given in the question. So we cannot go or we cannot use this formula. Now the second formula is the step 1, step 2 formula. In the step 1, you are going to make three columns, one for takeoff, the second one for landing, and the third one for zero fuel mass. In the takeoff mass column, you are going to write a value which is the lower of performance limited takeoff mass and maximum structural takeoff mass. So we do not have the two different types of takeoff masses here. Only one takeoff mass is given. Let's use that, 85,600. So let's write 85.6. Now in the landing mass column, you are going to write a value which is the lower of performance limited landing mass and maximum structural landing mass. But in this question, landing masses are not given. So let's leave that column empty. Zero fuel mass is again zero fuel mass plus fuel on board or takeoff fuel, right? So we have two zero fuel masses given to us, 75,500 and 74,500. So select the lower one, 74.5. Fuel on board. What is the fuel on board? Now that is takeoff fuel. Fuel on board is nothing but takeoff fuel, which is 11,000. So 74.5 plus 11 is 85.5. Now your regulated takeoff mass will be a value which is the lower of 85.6 and 85.5, so 85.5. Now step 2 is regulated takeoff mass equals to dry operating mass plus fuel on board or takeoff fuel and payload or traffic load. So we have regulated takeoff mass, we have fuel on board value. Do we have payload value? No, we do not have payload or traffic load value, correct? Directly, but we have useful load. We know that useful load equals to fuel on board plus payload. Fuel on board we know it's 11,000, so we can calculate payload. Okay, so payload will be equal to useful load minus fuel on board. So 22,500 minus 11,000 is 11,500. Okay, so now we have all the values. So DOM will be equal to regulated takeoff mass minus fuel on board plus payload. 85.5 minus 11 plus 11.5. 85.5 minus 11 plus 11.5, that is 22.5. So 85.5 minus 22.5 is 63. So that means DOM is 63,000 kg. Okay, that is 63,000 kg. Now this is the second way. Now there is one more way in which you can calculate your dry operating mass. The third way. Now we all know that dry operating mass plus useful load equals to your takeoff mass. Correct? Dry operating mass. Dry operating mass plus useful load equals to your takeoff mass. So we have this values given to us directly. We can make use of them. Dry operating mass will be equal to takeoff mass minus useful load, and takeoff mass 85,600 minus useful load 22,500 is 63,100. Okay, so here we got an answer of 63. With this formula we are getting an answer of 63,100. So you are going to select a value which is closer to this value, 63,000. If it's given that, you go ahead with that, or you select this 63,100 if that is given. Okay, so this is how you do this question. I hope you have understood all the 10 questions that I have done in this video lecture. You have learned something new today. Best of luck. Keep practicing more and more questions. Do watch the lectures that I have uploaded to my channel. There are so many lectures you will find of payload and weight and balance. I request you all to share this particular video lecture with your friends who are also preparing for exams. Subscribe if you haven't yet, and hit the like button if you have liked this video lecture. Thank you for your time.